Hello everyone, this is the second part of methylation analysis tutorial. So first of all, after following the first tutorial, installing the package, what you need to do is perform the analysis. So this is the command for installation of XAMPP. There are some potential errors which were discussed in the previous tutorial, so you can just follow those and install the XAMPP software, right? So if you want to have a dry run or you want to run the test data, you can use this information and first write the library XAMPP and then the test data, and you can do that. But I'll use an example which I already have stored in my computer, so to make you understand how to access the information from your computer for the methylation analysis. So first step is to write library XAMPP. Just copy it and then paste it here and click enter, right? Library bracket XAMPP, and it will start loading the XAMPP package, and after loading all the dependencies and packages, at the end you will see that the XAMPP has been loaded. Just wait for a while, and here you can see that all the libraries DMR, cat, XAMPP data, loofit, and for each bump hunter, everything is installed now. The package XAMPP is loaded, right? So what you need to do is next is to know which data you will be accessing here. Let me share you the data sets. For instance, I just go here, I just click anything for instance here I am going to the check data, check from, yeah, now this is the methylation data. Here you can see that two pair of sample represents one patient. For example, grn.idat and grn.red.idat is one sample, and here you can see R06C01 is the first sample, R06C02 and R06C02 is the next sample, and so on and so forth, right? So here you can see all these data sets organized into two pairs, right? And the other thing which is XAMPP requires is one input file. You have to make a CSV format file. Total number of samples are 96, and total number of files are 96, and so total number of samples will be 48, right? So depending on what type of analysis you want to do, you can make an input file. And in this input file here you can see I've not included all the samples to save time. There are a set of samples out of those data sets. For example, few are normals, few are carcinoma samples, few are adenoma samples, and few are metastasis samples, right? So you have to organize them in this format before performing the XAMPP analysis. For example, here this is R04C01. So let me find it here. Yeah, this one. So this is the R04C01 sample, and that is a Centrix ID. And you can see that there are three groups. One is GSM, then there is this R04C01 and one other Centrix ID, that is 90469211126, right? So that is you have divided the sample name into different columns. One is Centrix ID and one is Centrix position. So total number of samples here are 3 plus 3 plus 3 plus 3, so they are 12 samples, right? So this is the Centrix ID, and this is the Centrix position that is extracted from the sample information, sample name. Here you can see in these names you can see easily, right? So yes, so what you next have to do is to go on the library XAMPP and start running the analysis. You have to load the data. When you will copy this command or you write this command of myload and give the directory where the samples are installed, it will only select those samples which are already included in the CSV file. For example, there are 48 samples. As you have seen that out of 90, total number of files were 96 and total number of samples were 48. But the 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 CSV file contains only 12 sample information. So what JAMP will do is, when you load the file, it will extract the information from the CSV file, and the only those files which are included in the CSV format will be loaded here. So it takes a lot of computational power. So before performing the JAMP analysis, you should know that you have a very good RAM and processor, right? So these are all the separated steps you have to follow. I've copied that in my notepad, and I'll also paste that in the comments box. So if you want to follow these steps, you can follow them easily, right? So yeah, so loading the JAMP will take a bit of time. So let's wait for a while here and see what we get. So here you can see that all the files are loaded, and the CPG fraction of each file is calculated here, and the values are here. The details regarding what are the values and what does that mean is beyond the scope. So first we'll just go through the process here. All the data is filtered and the CPG fraction is calculated, and the next step what is to, as you can see, you may want to process champ.qc, or you can go for cpg.gui. That will open the graphical interface of cpg.ui. And wait, let's see here. Now here you can see that this is the graphical interface. It is open into the Internet Explorer. All the CPG present in all different chromosomes, starting from the first chromosome to the last chromosome, are shown here. You can download these graphs into image files. For example, here you can see that different options are zoom in, zoom out, and select, or you can see here is where is the download? Yeah, this one. Download the plot. When you just click it, it will be downloaded into the PNG file like this. So you can download all the plots, graphs separately. For example, if you want to download this one, just download it and you can open the file. So in these 4 samples, in these couple of samples which we have loaded, these are the CPGs reported in different chromosomes and different regions, in UTRs, exons, or introns, and so on and so forth. So next thing, if you want to do the quality check, you can do that, or yeah, so you can do whatever next step you want to do. For instance, first I have to stop this because it was running, and after that this my DMP is before that I have to run the normalization step. That is my norm, that is jamp.norm, and when I paste this information here again, after loading this, it will take a bit of time because each step will take a couple of minutes, because it's very it takes a lot of computational power. So you have to wait after each step for some time, and keep that in mind, that your computational power of your computer should be good for the analysis. Here you can see that it is saying that 3 cores will be used to do parallel BMIQ computing, right? So let's see what we get after this this command. now here you can see that the my norm is completed, and the files are saved in /champ underscore normalization / folder. You can access that, or if you want to save that into a text file, you can also save that using the write.table command. So the next thing is to use the mydmp command, and again when you will paste that command, it will take a bit of time, but good to know that it's already done. Here you can see that total number of information is normal are 4 samples, tumor are 9 samples, and the levels and everything is calculated. And next thing is, if you want to view that in a graphical user interface, you just write dmp.gui, and then after writing that, you just enter that information, and then wait, and that will be open into Internet Explorer. So here you can see this is the overview. You can select the significance value and log fold change cutoff. So I've just selected 0.075 log fold change and p-value 0.05. So here you can see that all the probes are mentioned here. This is the probe ID of Hox A3 class gene that was differentially that methylated in this data set with the fold change of 0.42 and so on and so forth. And yes, and the next thing, for example, if you want to search the gene here, just write the gene or click submit. No, maybe this is not the place where we have to search it. I think when we will go to the gene header, then we can do that. So next thing, if you want to check the heat map of these results, you just click the heat map, and you can find this information. You can also download this heat map using the download option mentioned in the in the above panel. Then all the information of different hypermethylated and hypomethylated probes. And if you want to search here, you can search the gene. For example, if you want to search a gene here, just write the gene name, and then you can see how many different methylations are reported in this gene. Right, so all of these things, and each gene with the hypomethylation and hypermethylation can be identified from this Internet Explorer output. Right, next thing is next step is to do the differentially methylated regions. So here you can see that differentially methylated regions or gene set enrichment analysis, but I'll be going with the my DMR, that is differentially methylated regions. What I will do is just write this command in the R console and click enter. Right, you can also do the this I am just using the R console because you can easily understand each step of this R package. Else you can also open a R script file, and you can paste all the commands and then run them collectively. So by the end of this by the end of the commands, you will get all the outputs. However, I will recommend you to first use the R console and check each command separately, that all the commands you are using during the analysis are working properly. Right, so now I am calculating the differentially methylated regions in the 4 normal samples and 9 tumor samples, and you can see here that total number of clusters detected are 8,418, and so on and so forth. And now it will also take a bit of time, a few minutes probably, and then we will get the results. Let's wait for a while. Please go through all the steps and all the results which are shown here, and follow each computing and bootstrapping steps, and check that everything is working fine. So by the end of this result, you can see that Bump Hunter detected 455 differentially methylated regions with p-value less than 0.05. Now if you want to view these files, you just write dmr.graphical user interface and click enter. After clicking the enter, it will again open the Internet Explorer file, which will take you to the results of DMRs. Let's wait for a few seconds. I hope it will open. Yeah, now that's open here, and it's still loading. The name of this file is Bump Hunter DMR overview. Let's wait for a few seconds more. Let's see what we have. Yeah, so now it's started to run, and when I'll go to check in the Explorer file, we can find the results here. Yeah, so just keeping the default threshold and clicking enter, here you can see the results will be shown in a while. Yeah, so now these are the differentially methylated regions, their start chromosomal position and the end chromosomal positions and the p-values and all the information, CPG tables, and maybe DMR plots are taking a bit of time. Let's wait for a few seconds so that the DMR plots will be loaded. Let's see. Okay, let's see something else first, and maybe during that time DMR index will be loaded. Let's go to the summary. Here you can see the summary of 426 genes enriched by DMR related CPGs and their heat maps. Now also the DMR plots are also shown here, so you can see all the hypermethylated and hypomethylated regions, and so on and so forth. So I think a lot of things are covered now. You can follow each step carefully, and you can do the analysis. Next is you can also do the my block analysis, or you can also do the gene set enrichment analysis. So what you have to do is to just write the command here, and you can get the output. So one more thing, that all the files, for instance, here you can see that my GSA and DMR and DMP, these all the information is saved here. So if you want to download or store this information in a text format, what you need to do is to go on your what you need to do is to just use the write.table file. Just save it in any place in the computer. That, for example, you just write .table equals to the destination where you want to save, and just close that bracket and just enter, and the file will be saved in your computer. So I think that's fair enough, and a lot of things are covered here. When you will read this command, then there are a lot of things you would already know, so I think I should stop, and I hope that you can follow these steps carefully and perform the differentially methylated. You can find the differentially methylated regions or genes or probes, whatever you need to find for your dataset of interest. Thank you. If you have any questions, you can ask in the comment box, and all the commands related to this analysis will be pasted in that comment box. Also the web link where you can find this information and the detailed information if you want to read will be also pasted. Thank you very much. Bye bye.